Again, for those that haven't met me, I think everybody's met me. So I'm Jared. Welcome to week 2 of the Clay 3D printing class. So last week, for those of you that were here, we talked mostly about this first step, the modeling step, and we went through how to create simple shapes using Fusion, Autodesk Fusion. Today, we're going to be going through the other 2 steps of this process. These steps are generally not as complicated. You're going to spend, when you're making a 3D print, you're going to spend 80% of your time in step 1, and then maybe 20% of your time in these other steps. So we should be able to get through both of these today. We're going to talk about how to take something that you've modeled and then slice it into the file that the printer needs, and then we'll also talk about how to physically run the printer. So how do you mix the clay? How do you turn the printers on? How do you get them set up? How do you get them ready to print? What should you watch out for while it's printing? And then what do you do to clean them up? So that's what we're going to do today. Uni has already had some questions about modeling. So if we have extra time and people are interested, we can dive a little bit deeper into some other tools that Fusion has to make models. But I also want to make sure that everyone who wants to be printing can be printing today. So we're going to start with that. And then you'll have all of the whole set of steps so that, feel free to come in during open studio hours and start printing things yourself. There's not really, the good news about the 3D printers is that unless you do something horribly, horribly wrong, it's hard to physically break them. You can do a lot of things that make your prints not come out correctly, but there's a lot of safeties on the printers, limit switches and stuff that will stop it from hurting itself before something goes catastrophic. So feel free to experiment. I've certainly made many a mess on those printers trying to figure out how to get this far. So you will not be the first to make horrible splattery clay explosions. So I'm going to start my screen recording here, and hopefully this software actually records the menus this time. We'll see. I tried it out. I'm pretty sure it will, but just as an example, I've made kind of a simple shape in Fusion using the tools that we had available in the first week. The only thing that you might not have seen that I've used here is the idea of a fillet. And a fillet is just a smooth transition for an otherwise sharp corner. So let me unapply that. You can see what that looks like. So this is the shape that I had before the fillet. And if I want to use a fillet, I'm just explaining this because this is smoothing corners is something you do a lot. It's in this modify menu. And we didn't really talk about this a lot in week 1. This modify menu contains all of the tools that take actions on already 3-dimensional objects. So in week 1, we talked about how this create section is all of the transformations that you do to 2-dimensional shapes. This modify section is all of the transformations that you do to 3-dimensional shapes. And one of the tools in here is this fillet tool. And what that allows you to do is select edges that you want to be smooth transitions and then smooth them. So just like extrude, it gives you an arrow to see the direction of the fillet. And then you can specify the radius of the circle that will be used to smooth that transition. So if I wanted a 15 millimeter circle to make that transition, that's how you would apply a fillet. So now I have a smooth corner in there. Now, of course, I could have drawn this in 2 dimensions with just a circle and then extruded the whole shape. But sometimes you'll have 3-dimensional shapes where it's not as easy. So that's just an example of a tool that you can use.
Can that be used for like a corner rather than a...
Yeah, so you can go the other way too. So for example, let's do it again and let's smooth out these corners here. So we'll do these 3 corners. And now you can see I can fillet those in as well.
What about the corner of a cube? Like that corner, can you...
Like a point? Yeah, so if I select a point, you can also fillet that, although a lot of the time, okay, so the way to do a point is to actually select all the edges around the point, and then you can fillet that in as well.
Oh, but it doesn't just do the point.
Yeah, yeah, exactly. It can't just do it, because then it would be like digging in to be able to do it.
So it fillets in XYZ.
It will fillet edges is the way to think about it.
Well, it's not weird, but it's interesting when you selected the two edges, it fillets to get forward. How does the computer know?
It's all math.
Oh, because you can't go that way.
Exactly. It is trying to do the best it can to satisfy all of the constraints of how to make this edge be a circle and this edge be a circle and this edge be a circle.
What if you would like to smooth the edge from the holes that you have?
Yeah, so you can do that too. If you want this to be a fillet, you can fillet that, and you'll end up with like a funnel. So that is another option. Although again, we'll talk about it in the slicer. If you have something like this, you'll have to be careful because doing this makes something from one direction very hard to print. And you'll see what I mean when we get there in the slicer, which I'm going to use this shape as an example for. Again, I made this simple shape. Please use one of the shapes that you've created from last week in order to slice. That way we can walk through it together, and if you encounter any issues, we can get to that. But I'm going to use this shape just because it's got some interesting things that will be good to talk about in the slicer. So I have this as a body in Fusion 360 that I've named example, but you can name your bodies whatever you want. I'm going to, now that I have this and I'm happy with the way the model looks, I'm going to right click it and I'm going to go to, in this menu, to save as mesh. Save as mesh is how you export one of the bodies from Fusion 360. It's always going to be one body. If you have multiple bodies that fit together or something like that, the way that you've drawn them, you'll have to do this separately and print them separately because they're separate bodies. We can talk about how to join bodies that should be physically connected. We'll talk about that later. That'll bring up this menu. Again, this format, this is what we've talked about. So you can have a 3MF, you can have an STL. The slicer that we're using works very well with 3MFs. There's more information in the 3MF, so that's what I would select. There are other slicers that won't use 3MF, so you have the fallback option of STL, but I'm going to use 3MF for this. All of these refinement options you don't have to touch. Fusion's going to do a very good job of guessing the resolution that this needs to be printable. Basically, Fusion is saying for any of the points or edges or faces here, how exact do I have to be before I'm within like the realm of physics? So it will change these. If you have a house, those numbers will change in scale compared to our 100 millimeter objects, but you'll never need to change these. Fusion is good enough at guessing what it needs to do that you don't need to go into those menus. We don't need to send to 3D print utility. So then if we hit OK, it's going to bring up this menu. You can't save the 3MFs to the Fusion cloud. It only supports F3Ds because, again, they want to keep you in the Autodesk universe, and we now want to exit it. So we want the second area down here where it says Save to my computer. We're going to make sure that box is checked, and then you'll just put this somewhere on your desktop or in your documents. Save it somewhere.
But it's already as a mesh, or is it just...
Once as we save it as a 3MF, it will be a mesh. So it is going, a 3MF does not have all of the procedural steps that would be contained in an F3D. So once as you save it as a 3MF, you can't go back from that file. That doesn't mean that you've lost it forever, right? Fusion still has it either saved to the cloud or saved to an F3D. That's why it's an export thing, not like you're not changing it in the software. So you won't lose it, but... Sure, yeah, we can go back. So over here on this left side, you have the tree of all of the things that exist as part of the drawing. It might be closed up like this, so you'll have the sketches that you use to create this in the first place. And then once as you use those 3D transformations, the 3D objects show up as bodies. And so the bodies that you've created is in here. And it's this body that I'm going to right-click on and then go to Save as Mesh to get that to come up. And then if you just hit OK, that's when we're going to get this box on where we want to save it. So I'm just going to save it into my Clay STLs file, but you can make whatever file you want on your computer. And that should only take a second or two for it to do that. And that's where we're going to end for Fusion right now, because now we're going to venture outside of the universe of modeling into the step for slicing. So I'm going to get out of Fusion now, and I'm going to go and open my PrusaSlicer application. And did everybody get my email that I sent about an hour ago? That's okay. So I have these files elsewhere, but if you are connected to the internet and you look in your email, there is a Prusa configuration file that we're going to use to sidestep all of the 3 months of experimentation that I've been doing with these printers, so that you'll have at least a baseline of, again, they're not perfect necessarily, but they're good enough that you can use these and they will work on the printers that we have. Some of the fun of ceramics is futzing around, and I definitely encourage that, but I also don't want you to just be squirting clay everywhere or have nothing come out, so these will get you close enough. And then once as you're at, if it's the first time that you've ever opened it, it's going to open up this like configuration wizard. Just hit finish. Don't do anything that it's saying, because we're going to use our own configuration for this. So in case you do ever lose these files or you get a new computer, there are flash drives that are attached to the printers themselves. That's generally because you're going to have to dump the G code that the slicer makes onto these to use the printers, but I have also put these configuration files on these flash drives. So if you need it, it is there. I am sorry they're USB-A for the people that have Macintosh. And it should be a .ini file. I'll make sure most of us have that file, have PrusaSlicer that looks at least something like this, and then we're going to go through the steps to import that configuration, and then we'll walk through. That's right, this is a different software than Blender. Regardless of how you create the model, so we'll create models with Fusion and Blender in this class, everything, step 2 and 3 are the same. Blender will also export 3MF files or STL files that will go into the slicer. So from here on out, regardless of how you've made the model, the rest of the process is going to be exactly the same to you. And in fact, if you ever want to do plastic 3D printing, this process will be exactly the same to you as well, just with different configurations for plastic instead of clay.
What's the fundamental difference between plastic and clay?
The biggest difference between plastic and clay for the 3D printing is that because plastic is a solid at room temperature the whole time, you have to melt it. So there are different things you have to do to get the extrusion to work when you are melting plastic and wanting it to solidify at the right time. And for clay, we don't need to worry about that, because clay, at least in terms of how the printer is interacting with it, will be paste the whole time. So we don't need to worry about what temperatures it's doing, what extra like melt stuff happens here. So there's some extra configuration that you do for plastic, which is also part of the slicer. We're just going to ignore those settings because we don't need to worry about temperature. So now that we're at this window and we have that Prusa configuration bundle file, what we're going to do is in PrusaSlicer, we're going to go to File, Import, and then Import Config Bundle. And this is what's going to suck all of the configurations that were in that file into your Prusa software. So navigate to where you've saved that INI file from my email or from the flash drive, click it, hit open, and it's going to tell you that you've imported 6 presets. And so just to double check that you have these presets, there are 4 tabs across the top of PrusaSlicer, as well as these 3 buttons at the top right. If you are on a button that is not marked simple, click simple, please, just so you're not overwhelmed. We can get into some of the things that are in advanced and expert later, but we won't need them to get off of the ground. So there are 4 main tabs in PrusaSlicer. They each have a set of configurations on how we are telling the printer basically how to move. The plater is what determines how the model that you're going to print is oriented in space, as well as things like scale. You can rescale objects here, you can rotate objects here, you can move objects around on the plate here, but basically the orientation and spatial awareness of your model happens in this tab. The print settings tab is where you tell the slicer what are the specifics about how I am drawing each layer that makes up my model. So how high do I want each layer to be? How many perimeters around the outside of my model do I want to happen? How thick should the bottom be? How thick should the top be? And then things like, if I have a part of my model that would otherwise be floating in space, what do I do about that? That's in here. There are some other options, like, do you want to draw extra lines around the outside so that when you're printing it, you can see where it's going to be on the plate before it starts printing, which sounds kind of stupid until you realize that what you're trying to print won't fit in where you have it on the printer. So that's a good option to, I usually have it ticked just as that like final sanity check. And then,
So these config settings are for the clay and its paste consistency that we're using.
correct, yes. And so if this is for a specific powdered clay that we're using, mixed to a ratio that between experiments with me and Lee have figured out works generally fine for the printer. And you'll all get to touch it and feel it, and I'll show you how to mix it, and I'll show you how to load it. That'll all be part of after we're done slicing. But that doesn't mean that you can't use other clays. We just haven't tested them. I would not use groggy clays. Again, we're going through pretty thin nozzles. I don't know that the grog would work well with that, but if you wanted to print, for example, porcelain, that would probably work just fine. I just don't know what the settings should be, and if you want to be in that situation, let me know and we can probably do some experiments together. The next one is filament settings. Typically, you won't be in here, but one of the things to make sure that you have set is that in here, if you drop down this kind of green flag menu, you'll see that there's two different user presets. There's one for our smaller machine, the Moore 1, with a thinner gauge dispensing needle. So there's the Moore 1 with the 13 gauge needle, and then there's the Moore 2 with the 8 gauge needle. This filament settings is basically telling the printer how fast does it need to extrude material to keep up with how fast the printer is moving on the XY axis. Again, because the bigger printer is using a bigger nozzle, it needs to extrude faster. That's what these settings cover. You can also see there's temperature settings and stuff in here. That's for plastic. We don't need them. That's why they're all set to 0.
So the 13 G8, this is for the fine.
So confusingly, needle gauge, which is what the dispensing needles are measured in, the larger the number, the smaller the gauge. So a 13 gauge dispensing needle is a smaller needle than an 8 gauge needle. I don't know why they've chosen to use that, but you don't buy dispensing needles in millimeters. But it's just the way that it is. Again, you have the configuration files for the 2 dispensing needles that I have installed here. We have other sizes. If you want a wall thickness that's in between these 2 things, there are dispensing needles available for that. I don't have a configuration file for that. Can you have it be halfway in between? I don't know. Try it. Again, these kind of cover the fine average range and the thick average range. I haven't really found anything that I don't want from these 2, but I'm not you and I don't know what's in your head. So know that you will get different effects, right? The finer needle on the smaller machine will make the layer lines harder to see and easier to blend. But if you want that kind of ribbed texture, maybe you want to print even small models with the thick needle on the bigger machine. It's just an option that you have.
Does that affect the layer height?
It will affect both the layer height and the wall thickness. Dispensing needle is a circle, so yeah. And then finally, the printer settings. Again, you won't generally be in here. This is just where we're defining the dimensions of the machine itself. So again, if you are going to print something, just make sure you have the right one selected here. So either 13 or 8 gauge. So I'm going to set up the example for my shape using the smaller printer with the smaller needle, but you can set it up if you want the bigger one. So I'm just going to go through all these tabs first off and make sure that all of them are set to Moore 113 gauge so that they all are correct.
What if they're off and one's for the 8 and one's for the 13?
It won't move the machine correctly. Again, there's not a lot that will happen catastrophically. You won't get a... No, because it doesn't know what these mean. I've just named them this way so that they line up. So these are set up for the 13 gauge and the 8 gauge needle that are on the machine. When we go actually look at how to physically run the machines, I'll show you what to look for. Because yeah, maybe someone had put a different needle on it and you need to put the one back. But we'll take a look at what this means on the machines themselves. All right, so I'm going to keep going, but if that import doesn't work, let me know. So I'm going to start on the plater tab. And you'll notice down at the bottom, there are two icons. One is a three-dimensional cube, and one is a bunch of slices of a three-dimensional cube. We're going to start on the one that's a filled-in three-dimensional cube. And so from here, we're going to go to File, Import, and then the first option, Import STL3MF Step OBJMF. It's the first option. This is going to bring up a menu for where to select that 3MF that we exported out of Fusion. So I'm going to export my example 3MF. And it's going to just put it fairly arbitrarily into your space here. Yeah, so it's blue because I don't have it selected. It will be green when I select it. So yes, yeah. So it is significant, just not in the way that Fusion is significant. So one of the things that you'll notice here is that Fusion is giving you a lot of options in this side menu to manipulate how this is represented in space, right? So it'll give you position, and if I move this around, you'll see that changes. It'll also give you rotation, so you can just change this, and if you highlight over it, it actually is helpful now, and it'll give you arrows about how it's rotating. So for example, if I wanted to rotate it, on the x-axis, which you can see is red here, by 90 degrees, I could type it in that box, hit enter, and now it's rotated. Sure, so all of these rotations, you can type in this box, and it will show you how it's going to rotate on the shape based on what box you have selected, right? So if I type in 90 degrees here and hit enter, it will rotate this.
There's nothing there that gives you hints that it's going to be unsuccessful.
So you see,
We'll get there, yes, we'll get there. There is. I will show you what to look for. If you don't want to use these boxes, Fusion also gives you options over here to have the same thing, right? So if you want to rotate, you can click this icon on the left, and it gives you a rotate widget, and you can grab these and move them around. It gives you a scale, so now you can scale if you want to scale in different directions. So that's why I say there are some things that are easier to do in the slicer than it is to do in the modeling software. So let the tools do what they are best at, and some of the things the slicer can do make these things a lot easier to do than what Fusion can do. One of the very useful tools in the slicer is this last icon here called Place on Face. And you'll see why this is important when we get to how to check if your thing is printable. Place on Face will highlight the flat faces of the object that you've created and give them these kind of white outlines. And it will just automatically rotate the shape and place whatever face you click onto the bed of the printer by doing that. So if I wanted to print this face on the bed of the printer, I can click this Place on Face and then here, and it will automatically rotate it and move it down to the bed of the printer. So that gets really useful, and you'll see why in a second.
So is centering important? So as long as it's small?
As long as it's on the bed, then you are probably fine. Again, I wouldn't put it all the way over here, just because there might be clips holding down the plate or something that it might run into. But yeah, it could be here, that's fine, or here.
Which one's the handles?
So now that we have it in the rotation and the scale and the place that we want it to be, the next step is to click this Slice Now button on the bottom right of the slicer. And it's going to go through an algorithm to try to draw each layer how it is going to move the extruder itself. And it represents this to you now in this kind of sliced up cube, trying to show you a color-coded view of what it thinks is happening on each step of the sliced model now. And Matt, you asked, is there any indication that something is printable? PrusaSlicer will do its best. So you'll see a warning here, warning, detected print stability issues. Because Prusa is saying, hey, based on what I know about how I've made these slices, this isn't going to print correctly. And you're on to where I'm going. The way that we can look for this is by looking over here at the color-coded things and seeing how this might go wrong, right? This big slider over here is a way of walking through the model slice by slice. So as I drag this down, you'll see that it'll give me kind of an X-ray view of each slice that it's doing.
And it's hollow, right? So it's automatically going with just the perimeter of it.
And that is because of something that I've done in the print settings. And we'll see how to change the options there in just a second. So as I go up, you'll see that it is printing solid infill. That's saying that's a solid layer because I told it that I want a layer on the bottom. So you can see there's two of those. There's one that's going diagonally this way, and then if I go up one layer, now it's going diagonally the other way. So knowing how to read these diagrams becomes pretty important to, if you try to print something and it's not printing correctly, usually looking at what the slicer is telling the machine to do is a good way of diagnosing some of these issues.
That's your choice to have it, or is that just standard to kind of knit it?
That is the default, but we'll get into some of the options that will change that. So as you can see, as I step through each layer, now it's doing 2 passes for each wall of this shape. Remember in Fusion, this was a solid shape that I modeled, and it is because of the options that I have in the slicer that is causing it to print this way. And that's why I said modeling things in Fusion is sometimes easier to just do it as a solid and do this kind of thing in the slicer. What I've lost, though, is I don't have an ability to control how the slicer sees the inside of this object. So if I wanted a specific inside, I would have to model it. But okay.
Accommodate to that. Like I'm thinking about like a bird feeder that maybe like inside had a couple different shelves.
You could model that.
And it would intuitively understand that it was already a hollow shape and would not hollow those things out of the inside. Like
if you modeled it that way, then there wouldn't be an inside. Yeah. And depending on how thick the walls of your bird house would be in this example, it might make some of those hollow as well. And we'll see what that means when we get into the options for this. Yes?
Default for the inside, like sort of, does it?
Yeah, so the defaults are what we're looking at right now. And it turns out that many of these are probably not appropriate. And that's why I did this example on purpose.
So are there ways to fix the interior here, or does it have to be fixed on the 3D?
No, there's many ways to fix it here, which we'll look at. Yeah, clearly this is not going to work. So the first indication that it's not going to work is the presence of this dark blue overhang perimeter. That should be the first tip-off that something has gone awry in your modeling. Overhang perimeter means the slicer knows that this is clay that is getting extruded into thin air. It is overhang. So the presence of this does not necessarily indicate, like it does not guarantee 100% failure. But if you see this, look very closely at what it's trying to do because it is a good indication that it will probably fail. Sometimes you'll have this overhang perimeter indicated like on the very corners of something as like the extruder is like cutting a corner and it's, you know, like a millimeter or two. That's probably fine. But in this next layer, you'll see this whole thing is overhang perimeter. that probably won't work. It is trying to print into the thin air of this model. All of this clay is just going to fall. And then anything on top of this is just going to fall right along with it, and it's going to start just making a pile of clay. So you'll see there's stuff printed on top of this. That's not going to work. Like, you can tell this model is not going to print correctly. And as we keep going, you'll see, okay, well, here's some more of that blue trying to like fill in the top of this circle. That probably won't work. And then as I get to this filleted edge, like this is printing over, you know, an inch of space. Like, this layer is definitely not going to work. So going through this line by line or layer by layer is a good way of double checking what is the slicer trying to do with your model that may or may not work. But again, it knows with this detect print stability issues warning, because it has also said, wait a minute, you've got a lot of this overhang perimeter, and bridge infill is another one that you should be looking for. As the slicer goes, it says, you know, this is more than like, you know, 0.5% of your model, something's probably wrong.
So if it's 0.3%?
That's probably fine. Like I said, you won't necessarily have zero overhang perimeter or bridge infill, because sometimes it will try to cut the corner on something round, or it will like have half of like one of the perimeters overhanging a little bit. That's probably fine. But again, if you see a lot of this, it is probably a good indication that it won't be able to support itself. One of the general rules of thumb with 3D printing overall, but especially for the clay printer, because our material is not good at supporting itself while it is wet, is that any angle that is over 45% will probably overhang too much to be printable. So, for example, this fillet in here, once as we got past about this point, these layers will probably start to fail. So things like shallow bowls are very hard to print, right? Because that angle is, you know, almost 90 degrees, not even 45. That doesn't mean that you can't print them. It just means that you can't print them without something else you have to do in the slicer. There are actually a couple issues with this that we'll have to do. So let's go through some of the things that we can do to improve how this prints. The first thing that I want to look at is, how do we take care of the fact that this overhang here will definitely not work? And one of the easiest things to do, and we don't even have to leave the plater in order to toggle this option, because this is something that people want to do so often, is that if you see over here, there's a menu for supports. And so this gives you a couple options. Support on build plate only says, I want to support this model, but don't create these support structures except on the build plate itself. Because I don't want it to, maybe I don't want it to create these support structures on top of the model itself. Because eventually I'm going to have to cut these away, right? When it's leather hard, I'm going to have to take a knife and cut off these structures. So maybe I want it only to start on the build plate. If you don't, like perhaps you have something in the middle of your model, like these circles, I might want to tell it, make these support structures everywhere on my model. There's another option here for support enforcers. We might get into that later, but that's an advanced move that I don't think is worth talking about right now. So for this model, I'm going to tick everywhere, because everywhere says I want to support it both inside, like on top of my model, and from the build plate. And now notice, it's something weird has happened here. And it's because I'm in this sliced view, not in the regular plater view. And because I changed options, it needs to re-slice it, because now it's making the machine do more things. And so you've noticed that it's added this green stuff as support material. So you can see as I go through, it's actually building up these towers of material that the unsupported layers in my model now have something to rest upon as it continues to go up.
But it's changed your model.
It hasn't changed the model. It has changed how the printer will dispense clay to support my model. So all of this green stuff, you will have to cut away at the end. It's not changing anything about your model. The model still exists, right? You can see it in orange. It appears exactly as it did before, but it is now being held up by additional clay that the printer is printing as it goes.
But the simpler thing to do is just flip the whole thing over, right?
We'll get there. So that solves one of the issues, right? So now this long overhang is now supported and will be printable. And the insides of these circles are now going to be printable. Not the bottoms, that's still a problem we haven't solved, but the tops, the tops here now have something to rest on. So these overhangs, not a big deal. But it still doesn't solve the problem that we had down here, where we have a bunch of layers and then it has a bunch of bridge here. And that's because right now that we've told the slicer we want to print this shape hollow. So the next option, which is still on the plater because it is still a very popular option for fixing a lot of issues, is this infill percentage. And this is telling the slicer how much do we want to fill the space in the model with clay. So it will give you options from 0 to 100%. I will tell you right now, you don't need 100% for clay. Generally around 25% is what we need. Okay, again, it's gotten wacky because we need to reslice it now that we've changed some of the options. And if we look now, you can see it is drawing additional paths inside my model to hold up these layers that would otherwise be bridged, that would be otherwise overhang. And you might want more of this, right? Like if you have some really fine detail, maybe you need more infill to hold it up. Maybe I go to 50%, right? So now it's drawing more of this infill. But just know that for each of these options that you tick, for all of the extra clay that it's putting down, you're adding time to be able to print this. Right, so before, you can see down here, down at the right, it will give you an estimate for how much the slicer thinks that this will take, based on the instructions that it's giving to the machine. This is not accurate to the second, but it is accurate to the minute. So the slicer thinks this will take 47 minutes to print. Before we added all of this stuff, so we'll turn off supports, we'll turn off infill. Let's see how long it takes to print now. It takes 25 minutes. So we've added 22 minutes to the print time just with the other structures that it's printing around that. So just know there is a cost to having this added to how you're slicing the model. Right? So those are the two big ones of, well, what happens if I find that my model is somewhat unprintable? Turning on supports and increasing the amount of infill is a good way to fix those things. Now, Liz?
How does the the printer know? How would we know when it's printed which one is the port and which is?
So that's what all of these color-coded options, like when you get it off of the build plate, it is just going to be down to looking at your model and seeing what parts of it you want to keep.
And it's easy to separate?
It is pretty easy to separate it. So you'll notice, let me turn back on the supports.
It's not just creating it as a single
Right,
shape.
so you'll notice it's printing it, it's printing it as a fairly sparse structure. So when it dries, it's actually pretty easy to just snap this off or take like a fettling knife and carve it off. It's not, the supports aren't solid, like it's trying to make it easy to remove.
It's like scaffolding.
It is exactly like scaffolding.
Please explain once more, like when we say support on build plate only, what exactly?
So I will show you. So right now I have it set to everywhere. And what that means is you can see on the bottom of this hole, which is part of the model that I want to keep, it is putting supports that are touching my model. If I say support on build plate only, it won't do that. It might be to the detriment of your model, but it won't put support structure on top of your model. Because again, you are carving it away, and maybe there's detail in here that I want to preserve super fine, and I don't want it putting supports on top of it. But again, you have to think about it. Does that mean that now my print is going to fail when it gets up into this area here? It might not. It's worth the experiment. Clay can bridge a couple millimeters. Because again, you think about a string of clay, you can connect it and it'll hold itself up for some small amount of distance. So again, if you see these overhang perimeters and bridge infills, it is not a guarantee that your print will fail. It is just an indication that your print will fail, that you should take a closer look at what it's doing. For these circles, the first time I printed it, I might go with this option and hope that this is enough to fill in itself without sagging. I might sit there and watch it diligently until it got to this layer before I walk away and start doing something else in the studio.
There's a cancel.
There's definitely a cancel. Yeah, we will show that in great detail.
So I had, or you actually had modeled it with a solid interior. And now it's showing me an open interior with a bridge that is just enough to cover the hole at the bottom.
That's correct. So if you give the slicer a solid model from Fusion, it will, by default, print it hollow unless you tell it how much infill you want inside the model. So it is that infill percentage that is you telling the slicer how hollow do I want this model to be. Because even in the world of clay, but especially in the world of plastic, you don't need 100% infill to make a rigid object, right? Think when you're hand building something in clay, you can get away with a basic skeleton inside a shape to hold it up. And the same is true here. Like I said, you can usually get away between 25 and 50% infill will generally be enough, because the space in between this infill here is small enough that the bridges will make it across that and not sag.
Just the supporting ribs.
Exactly. Yeah, you're basically printing supporting ribs.
And they are of different size depending on the percentage.
Right, because yeah, if I turn this up to 70%, you'll see that that spacing and that infill gets closer and closer. But also you're adding more time to the print, right? So if I put it on 100% and supports everywhere, we've gone from a model that took 25 minutes to print to a model that took 41 minutes to print, and now we're at a model that takes 52 minutes to print, because now it is printing every layer solid. So.
And where are the minutes, please?
The minutes are down here on the bottom right.
You do by percentage infill, not like thickness of the wall.
So thickness of the wall is a different option, and we'll get to that. Again, the last thing that I wanted to talk about, and Liz already got there, is that when you are printing a model, you should also think about how the printer prints, right? The printer is printing layer by layer and moving up in the z-axis. If I wanted to print this and I didn't care about how the direction of those layer lines look on the object, I can print this in a way that doesn't require any supports or any infill except for the top of it, right? So if I use that place on face button, I can tell that if I print it this way, there's no structures that are overhanging now, right? So if I didn't care about the shape of the layer lines, I would print it this way, right? Because now there is no overhang except for this top, right? So this might be enough to bridge, or I don't need supports, maybe I'll turn on some infill, right? So now, even with infill, it's only going to take 34 instead of 47 and save a bunch of clay.
Is there any effect for firing or for shrinking based on how the infill is done?
So if you're firing with something that has a roof, a fully enclosed thing, I would suggest putting a couple holes in the bottom just so that it doesn't trap moisture inside. Typically, it's probably porous enough that I wouldn't worry too much about it, but I have fired all the way solid pieces that were 3D printed and it seems fine, but I'm not going to guarantee to you that that's true.
So you can print on a small slab so that you can use that as a base?
Correct. So that's the next thing that we're going to get to, right? So this is all of the default settings where it is printing both the bottom and the top of the shape and the amount of infill that you're specifying. That's all that we can get to from the plater. That's already a lot of options that we have to play with. If you want more options, the next place to go to is the print settings. The print settings have more configuration for what you're telling the machine to do. And the big things in here are perimeters, spiral vase, which we'll get to in a second, and then solid layers. So, for example, like Liz says, especially if you have a big object, you might not want the printer to print the bottom of the whole object. If I can just take some clay, run it through the slab roller, and then just print onto the clay as the bottom of my piece. If that's the case, I can come over here to solid layers in the print settings and turn the bottom off. Right, so now if we go back over here and look at the slices, now it's not printing the bottom. Because maybe I'm printing that onto clay, or maybe I don't care about the bottom. That's fine.
So, excuse me.
Yeah.
When it says bottom 2, it actually is printing the bottom and then beyond printing the bottom at 2 millimeters?
It is not millimeters. This is in the number of layers of clay.
Okay.
So 2 means 2 layers of clay, 2 fully printed layers of clay.
So it will in fact print 2 layers, and then if you choose 20, which I just did, after those 2 layers, then it'll print my grid inside as stability?
Well, if you choose 20, right, that's going to be a very thick bottom of fully printed layers.
I meant from the previous platter where we looked at the interior. So if you go and choose 20 infill, then the bottom looks as if it is empty.
Yes, it is. Yeah. So even if I turn this to 0, and I'm on 20% infill, it will still print the infill, because the infill is part of the interior of the shape. So that will still be there. If you don't want a bottom but you want a top, you can do that. If I don't want a top, I can turn off the solid top layers. Now for this shape, if I don't have a top, I don't need infill either. Right, so now I have a shape that's almost fully empty, right? Or if I wanted this to be a vase-like object, I can turn the bottom back on. So now I have something that has a bottom and walls. I don't know why I'd do that with this shape, but just as an example.
Is that between the closed bottom?
It will be closed enough. Like this will make a solid bottom, especially if you glaze it. But yeah, you can always print on the slab if you want something that is not just drawn as a bottom. And I have tended to like take a rib and smooth these out after I print them as well. The next setting that you can look at is perimeters. So perimeters is how many layers of clay do you want around the outside of the object. 2 is generally a good amount. You can do 3, you can do 4, and it will make the object now thicker before it starts infill, right? So in the case of this object, 4 is enough to make the whole thing solid. You could go down to 1. And now this is a much thinner piece that's going to have more infill. Or if I turn infill on, it would have more infill. Right?
Can you handle it if it's like that?
Yeah, and that's why I like printing onto paper, because then you can slide the paper around with your model on it, and then just wait, an hour for it to get to leather hard, and then you can peel the paper off and do whatever else you want to do with it. I've been using newsprint. You could use parchment paper if you want to. I like newsprint because the clay tends to stick to it pretty well. You want to get it to, because if the nozzle starts sliding clay around on that first layer, it can make a mess. And you'll see, it might happen to us today. So those are some of the options that you have here. And if you ever find yourself not remembering what they used to be, Prusa gives you the option with these kind of back arrows to set them back to the original. So unless you resave over top of these, you'll see this says Moore 1 modified because I've been changing things. Unless you resave over it, those back arrows will always get you back to these defaults, which is a good, you have safety here, right? So like you can see my infill is a different thing. Now you had asked before, what if I want a different pattern of layers for the bottom or the top of my shape? In the print settings, in the infill section of the print settings, it will give you options for different forms of how it fills in the layers. So I'm going to turn in infill density back to 20. The fill pattern is for infill, and then you have a different choice if you want it for the top and bottom, the things that are visible from it. So monotonic is just the back and forth diagonals, but you have quite a few options. So you can do concentric circles, you can even do Hilbert curves if you want to. So depending on how, if you're going to keep the layer lines, if you want it to look different, you can have it use a different pattern to fill in how the bottom looks. And that might be cool.
Could you import your own?
Uh,
Or is that
I
just
have not tried that. I don't know. The answer is probably yes, but might require some software tweaking.
Because I mean, at that point, it's texture and pattern.
Right. Yeah, so it could be cool, yeah. So again, here's just the concentric fill lines will give you, concentric circles around your shapes. So
Undo it and redo it. Does it
I see, thank you.
scramble the math and come out a little bit differently, or is it basically?
it is running the algorithm every time. That's what happens when you're hitting slice. I can't guarantee to you that it is predictable because I don't know that, but it should be pretty close to that. In fact, the algorithm that it's using, this is just a sneak preview. If you go into the expert options, you can actually change the algorithm that it uses to some different algorithms. Don't do that, but you can if you want to. That's why they hide it under expert options. The last thing that you might or might not notice on your models is when the machine is changing layers, there will be a small kind of seam because it's sitting in one place and then moving up before it starts traveling again. You can decide how it puts those seams on your objects. Random will just have the machine move to a random spot, so these kind of little pock marks will be distributed randomly around. Nearest will say, move the smallest amount you can as the machine to start the next layer. So if it prints the square first and then prints the circle last, it'll make the next seam on the circle and then print the rectangle last. Aligned says make them all in one line, so start at the same place for every layer. And then rear tries to guess what the back side of your object is and print it on the back side, which means you might need to rotate your object on the plate. And this might be like if you're printing a bust, you don't want those pockmarks to be on the face, right? So you would say print it on the rear and then rotate it so those seams are along the back of your object. You do also have options for support material in here. It doesn't give you a lot in simple, but if you find that the supports that are being generated are too close together or too far apart, if you go into the advanced parts, it gives you a lot more options. Again, usually you don't need to do this, so feel free to leave it on simple and leave these options alone. But know that there are a lot of things to tweak here. And that's what we've been doing the last 3 months. That's why we've provided you the defaults for this.
And the default for infill
Is 0. So the default is 0. The default fill density is 0. The default supports is 0. And the pattern is monotonic. The last option that I want to talk about, which is in the layers and perimeters, is this spiral vase mode. This is a special mode that if you tick it will change a bunch of boxes, and it will tell you that. It will pop up a thing that says it's changing a bunch of things. But what that does is if you know you're printing something that is vase-like, it doesn't have to be a vase by like the ceramics definition of it, but anything that is one perimeter that doesn't have any disconnected pieces can be printed in one pass, so one perimeter, and doesn't need any infill or top. That's a vase by Slicer's definition. Instead of going layer by layer, what it will do is just continuously print while moving up in a spiral. And what that does is it saves a lot of time printing. I don't know that this will slice the correct way. So yeah, you can see we've gone from a model that took 20 minutes to a model that takes 10 minutes in vase mode. But it didn't print the insides because these are disconnected. It's not a vase. So this is in print settings, spiral vase.
So that's when you don't want anything inside.
Correct. It is if you know you are printing something that is just a contained vessel, it is a good way of saving time if you are happy with all of the caveats of it. You don't get multiple perimeters, you don't get a top, you don't get infill.
In pottery, in ceramics, isn't that pretty much what we do?
I'm sorry.
You can a lot of the things that I printed over there, I printed in spiral vase mode. Yeah. Yeah. So that's a good option to have. But maybe you want something that's thicker, or maybe you want something that has a top, or maybe you want something that has multiple circles in it. So it's not necessarily the default, but it is very useful to us. All right, that took a little bit longer than I thought, so I want to get into working on the machines. So let's take a field trip over to the machines themselves. I'm going to pause this recording and move the camera real quick. Yeah, for both of these machines, they actually operate in a pretty similar way. So yeah, the bed moves the y-axis, the gantry moves the x-axis, and then there's a screw that moves the z-axis. So these are the two machines that we have. We have the smaller Moore 1 and the larger Moore 2. They both function almost identically except for the size of the print bed. So if you learn one, you'll know how to operate the next one. I just want to walk you through some of the parts of these machines. So before I start, you're going to ask, why is there a bucket of water? Why are these things wrapped up in little tubs of water? One of the things that we are fighting while we put these machines away is that there's going to be clay that stays in parts of these machines. And if it dries, it's very annoying. So we are trying to keep everything that is too annoying to get clay out of wet. There are ways that we can solve that, but this seems to be the easiest one so far. So I'm going to unwrap this just so you can see all the parts. You might want to be on this side, actually. I realize this is kind of a small space, but at least we've been given a space at all. The machines turn on slightly differently. The Moore 1 has this button in the front, and then the Moore 2 has kind of like a computer power switch in the back. But you'll notice the screen looks the same. The controls on these are identical, and most of the parts on them are identical. So we have the primary extruder. This is what's pushing clay from the tube that's currently in the water bucket out onto the print itself. The actual dispensing nozzle is sitting in this tub of water so that it doesn't dry out. There's actually an auger inside of here. That's what's pressing the clay down through the nozzle. We also don't want that to dry out. From there, there'll be a tube. So just imagine the tube in here, and we'll get it set up for you guys in just a second. That goes over to one of these containers. And so this is what we're going to end up filling with clay. And that will screw onto the front of this machine. And this has gaskets in it, so it's kind of hard to push. But you'll push it onto here and then screw it in once it has clay in there. This is what provides the pressure to get the clay through the tube and into this extruder. So this will also be moving, just slowly. And running this in and out is part of the setup of the machine, and so we'll get to that. Now there are three options in here: system, which you probably won't be in very often; tool, which is where you do all the setup for the machine; and then print, which is where you actually tell it to start printing. So if you go into the tool, you'll notice there's a couple different options in here. There's manual, stop, materials, and level. And depending on what you're doing, you'll probably be in these menus for some part of the setup the whole time. I'm going to make like a operation manual of this, maybe by next week. It's on my list of things to do. I just didn't have it for today. Manual lets you move all of the things on the printer yourself, right? So for instance, I want to take this out so that I can start setting up the machine. And the direction I want it to move in is in the Z-axis. So I'm going to find the Z, and I'm going to tell it to move up, right? Just so I can get this out of here. Cool. But you can also move it in X or Y. You can also run the extruder from here, but that's not the best place to do it. So don't use the E1 here. There's a better menu to do that in.
So you basically can extrude, I guess, just with your fingers.
Exactly, and you'll have to do that because part of this process is getting enough pressure built up in this tube and through the extruder that when you start your print, it's ready to go. Because it takes a couple seconds for it to build up all of that pressure before it's extruding consistently. So the 10 seconds before you start your print, you'll prime it just to build that all up, and then stop the prime and immediately start your print. And we'll go through all of that. So there's a back arrow here. The next stop is pretty self-explanatory. If anything is happening on the machine, stop will stop all of the motors. So if it is currently operating, usually there's another one of these stop icons on the screen that you're on, but if you're in some other menu, this is the way to stop everything. So this is one of the ways that if you see things start to go awry, hit the stop button. Materials is where you'll do the setup for getting the clay extruded, how to prime it, and then also when you're ready to clean it up, how to run the rest of the clay out of this tube and reset it back to this position. That will all be in this materials menu. This is a little confusing. I don't think they have a user interface engineer on the Tronxy team. This big number here is controlling the speed of the extrusion. It's an arbitrary number. I don't think it is meaningful other than it goes from 0.1 to 20. 20 is the fastest it goes, 0.1 is the slowest it goes. When you are setting up this machine to get the clay to come through the tube, or you're resetting, like you want this to go from fully extruded, like I'm out of clay, back to this position, you can use 20. 20 won't print correctly. It's running too fast. Like it's too fast of extrusion for the machine to keep up with. This setting doesn't mean anything during a print. It's all just for setup. So really the only thing you'll be doing here is clicking the number, deleting everything, hitting 20, and then either running this in or out. There's an icon down here at the bottom that has its best representation of the tube with this extruder. If you click it, it's just the tube, and if you click it again, it's just the extruder. Most of the time, you'll be running it as just tube, because this thing takes orders of magnitude longer to prime than this does. So if you see, like if I start extruding, you'll see this is starting to move. That's as fast as it goes. This goes very slowly, as you can see. This is 20, so this is as fast as it'll go. It will never even, it won't print this fast. But you can see, like it's a good 5 minutes to traverse the length of this tube, which I am saying because part of cleaning this up is getting everything reset. So if you've printed this much tube, you're gonna have to run this forward to get all of the clay out of it, and then run it all the way back to get it reset. So if you know you need to leave at 5 o'clock and it is 4:30, don't think that you can keep printing. It takes about 20 minutes to get everything reset. So it is somewhat fiddly, and here you can see that stop button again so that I can stop it from moving, and then I'll go backwards. It's going to give you a warning that says be careful going backwards if you have the tube attached. This seal will create kind of a vacuum, and if you have this running for more than a couple seconds while there's clay in it, it will start breaking the machine. this motor will be unhappy. It won't break the machine. Yeah, it won't break the machine. Yeah, and I'll show you what I mean, because I'll run it up against this metal piece just so you can see what I mean. It is not going to physically harm the machine in a couple seconds. If you leave it running in a state where the motor can't move the mechanisms, it will eventually overheat. But I will tell you now, you will not be able to stand what it does for the amount of time it will take to overheat it. I'm going to keep talking while it is getting to a position where it will be in that state.
And why is the extrusion not a full rotation and just a small amount?
It shouldn't be rotating at all. The whole idea is that this motor is rotating this to move this shaft in and out squarely. So it's just, this is a badly machined shaft, which is why it's still kind of wiggling. But yeah, the intention is this doesn't rotate, it just presses. There are build plates here. This is what we build on top of. You don't have to use the paper, but like I said, I like the paper. So this will end up getting attached to here with these clips to hold everything down. Now I'm waiting for it to start to jam, and you'll hear what it sounds like in just a second. That's what happens. This is not breaking the machine, but you can clearly see you don't want to leave it like that. If you mix up clay that is too stiff, you'll hear the same noise. It's a good indication that you didn't mix it to the right ratio. There is some leftover here. We can pass this around. This is kind of the consistency that the clay for this extruder is like. You'll mix your own clay for this. So it's not throwable, but it's not slip. So,
You talk about how in the beginning it has to prime. Is that another good reason why we do that outline of the base?
yeah, just to make sure that it's extruding consistently, but that's not enough to prime the whole machine. You'll still prime manually.
Beforehand and hit it.
Correct. And it'll do that last perimeter just to give you that guarantee that it's priming consistently. So there should be 4 clips. There are Bulldog clips, or there's these clips for this machine. I don't know where they have all gone already. But anyway, the whole idea here is just to be able to hold the paper and build plate onto the bed while it's moving around. We'll find them. I'm not that worried about it. So we've gotten everything hooked up. We've got the tube with clay in it. It's primed. The next thing that we need to do in that tool menu is this level button. And there's only one option, which is manual. So we want to do a manual level. The first thing it's going to do is reset all of its safety parameters. So what it's doing is it's finding where its 0 point is. Now, what we do from here is using the thumb screws that are on the bottom of this bed, we're going to make sure that it is flat compared to the nozzle. This is something you probably want to do every time, although if you've done a print and you're going to print another print, you don't have to do this. The reason you might want to do this every time, or at least when you start using it for the day, is that you will level differently if you're printing onto a slab of clay, because it's thicker, than if you're printing onto a piece of paper. So the way to do this is that you'll see there's all of these targets that show up on this interface. When you click a target, it's going to move the nozzle to that point. What we're looking for is we're looking for a kind of cardstock sized gap. So you're just going to turn the thumb screws to where you could slip like a piece of cardstock underneath it. Not really any tighter than that. Because we're printing at such thick layers, we don't need to be like right onto the bed, which is what you would do if it was a plastic printer. But so now we're just going to go around the corners and check that level in all of these places. So that can go down just a little bit. That's good. Corners. Right. So, right. Like if I were to take like a couple, like a couple pieces of paper, could I fit this underneath? Right. Like a piece of cardstock.
So
It is manual, and you have a lot of forgiveness in this step just because of how thick the layers are. If you start the print and you see that the clay is not sticking to the paper, it is highly likely that it is too high and you should re-level it. If instead you start the print and you see it start to drag the nozzle into the paper and it's tearing the paper, it's too low and it has gone into the board itself.
Wouldn't it be good to just have a standard little, something?
You could, and for this needle that's fine, right? But if I switch this out for a thicker needle, now I need it to start a little bit thicker. It's however thick the layer is what's going to determine how far away it goes. You'll get an intuition for it, I promise you.
Well, I just mean that the gauge is what you would be changing, not the tip.
But the gauge is going to put more clay out,
Yeah.
so your layer will be taller.
Yeah.
But you're just measuring this. He's measuring the height.
Right, but I want it to start at a higher level if the needle is thicker.
I see.
So you'll get an intuition for it, and it's pretty forgiving. And so once as you do the corners, just check the middle. If you have all 4 corners, the middle should be fine. Otherwise, something has gone very weird. Maybe you don't have the clips on correct. So this looks good to me in terms of all of the setup. So the machine is basically ready to go. Just in terms of tips and tricks, I've noticed that it is easier to get this to screw on if this thing is not all the way in the back position. So I'm going to go into materials and I'm going to have just the tube, although you can see what happens if you have it on both, move a little bit forward. So you can see this is also extruding. I don't need it to be, but that's fine. So usually what I'll do is I'll line up the end of the plunger with the end of the metal. That's a good spot where this will engage without like losing too much clay to the space that the plunger takes up. So something like that is good.
What does that red thing say?
So these just say low, medium, and high, which is speeds, but even high only sets it at like 3, which is not fast enough. So just type in 20. So that's the setup. I'm gonna actually set it up for you so you can see it actually go through its whole thing, and we'll do a print together, and then we'll see how much time we have left from there. Also I'm gonna show you how to mix the clay. It's not as complicated as you think. So I have a scale here. It's one of the gram scales. You can use any of the gram scales in here for this purpose. I'm gonna put my container on here, zero it out. The clay that we use for the printer is in this bag here. It is Laguna B-Mix clay. And you can see that on the bottom. If you need to check it, you can see it says B-Mix 5. That's the clay that we're looking for. There are a lot of bags of white powder in here, so double check that you have the right one. This is very similar to the You Betcha. It's in powdered form so that we can get the ratio correct. The out of the bag You Betcha is too stiff to use in the 3D printer, so it's just easy to mix. I am looking for a scooper. So the amount of clay powder to fill one tube, or the amount of clay to fill one tube is about 1 kilogram. So the ratio that I've been using is 685 grams of clay powder and 315 grams of water. So I'm going to put 685 grams of clay powder in here. You don't have to be perfect, but if you're off by more than 2 or 3 or 5 grams, you'll see the difference. It will print differently. Exactly, yeah. So you are playing a balancing act. We want it to be as stiff as possible because that will make the prints come out better. But at some point it is too stiff for the machine to dispense. You can try going a little drier, maybe 690 to 310 or 695 to 305. At some point you will reach the point where that motor starts to stall again. You'll hear that horrible noise before it can get the clay all the way through the tube. And then you'll know that you've hit the end of the road.
In timing wise, it has to be fresh you make it before you.
I have some leftover, like when I made a tube and only used half of it, and that's what's in that container out there. The problem is, even wrapped up, it starts to dry, and so, yeah, and then it might not extrude, and now you're stuck with a tube that is too stiff for the extruder to press, and it is a mess to clean up. I have successfully printed with some of that leftover clay, but especially for you all, you're gonna have a better time just mixing it than trying to mess around with the recycled stuff.
Is there a way to reclaim it or anything like that?
Yeah, I mean, it's just clay, right? Like, this is the same as the You Betcha clay.
Right, but to like rehydrate it.
Yeah, and if once as you get a feel for it, start using the clay that's in that other container. Like, once as you're used to like how it feels, go for it. Just know that it means that you're not going to be, if it starts to stall the motor, like you took the risk. There's no trick to mixing this. It's not as hard as you might think. Because it is dry powder, it actually rehydrates pretty well. You just want to watch out for making sure there's not big. Oh, can you spin it around? So we're good. So you can see, like, it'll get kind of lumpy. You just want to make sure all these lumps are out and you don't see any dry spots. So it only takes maybe a minute to get this to where we need it. And again, it's not slip. It's somewhere in between. So again, I'm just looking for noticeable chunks, noticeable dry spots, and getting those worked in.
But if you have one, if it hits a dry spot, big trouble, right?
Right, yeah. So you do want to make sure that this is consistent.
So it looks as if one tube would be enough to make a glass this size.
Yeah, so for example, if you grab that vase, you can see exactly how much one tube is because there's a line on there, the big one. Yeah, so you can see there's a line on there where I had to start a second tube. All right, so we're kind of well mixed here. And now the next step is, how do we get this into the tube? And again, I have not found any secret tips and tricks for this. The way that I found the best to do it is to scoop out more or less as much as you can, although I usually do this in two kind of steps, right? Take it off. This gives you a chance to make sure there's not any lumps in it, because right now I can feel a lump, which is good. So touch it. It's messy. Just go with it. I'm trying to get out any of the lumps, so there's still a lump here that I need to mix. Get that out. And then the way that I found works best is to just make it into kind of a snake. And then in the tube. And then make sure you tap it down. You can see it's clear, so you don't want, little air bubbles are okay. They'll get popped by the other extruder. But if you see big air bubbles in here, that's a spot in your print where it will be extruding nothing. So really make sure to try to get this as compact as you can. I mean, if you come up with a better solution, I'm all ears.
Another extruder.
Extruders all the way down.
Yeah, it's just all extruders.
Just got a piping bag.
Could be a piping, but that's not a bad idea.
Yeah, just zip it in.
But they're clay, right? I mean, canvas.
Yeah, the wax canvas.
No, wax canvas.
When you can use it again.
Yeah, you can wash it out.
Cool. So that is a loaded tube. And I'm going to go wipe this down so that we don't make a mess of anything else, because this will be sitting on the table. It's not a waste, because we'll put it in the bucket, right? So there's no, this also, if you print things that you don't like, put it in the You Betcha reclaim bucket. It's the same clay, so There's no waste. It can go to other projects. I'm gonna go wash this off. So something you'll notice is that you want to leave enough space up at the top here that's clear to fit that plunger into, right? So you want to leave that room. And so another trick to this is that because this is plastic and it's going into metal, it is very easy to cross-thread this. So pay attention when you're putting this in that it is actually straight before you start twisting in with great force, right? Because you can see right now that's not straight. If I start just to turn this, it will cut into the plastic. So you'll feel it. It'll get significantly easier when you have it actually lined up, but it does take some finagling before it's lined up. My hands are slippery with the water. There we go. And it'll screw in almost all the way. There is going to be some of the threads left, but you can actually look and see, if you look, like the plastic is all the way into there. So don't expect, if you see the threads, that doesn't mean that it's done. So that's the extruder setup. We've got this leveled. We're going to take one of the tubes that has been sitting submerged so that it doesn't dry out, and now we can plug that into here. I'm not going to plug it into the main extruder yet because I want to get all of this through the tube, all of the old clay and whatever the water has turned it into. So I'm going to go back into Tool, Materials, push that button so it's just on the tube, set this to 20. Thank you. Start pushing. And you'll see it start to move through the tube. So I can see where the new clay starts. So I can stop it around here. Cool, so that's primed.
There's a bubble, big bubble.
Yeah.
Is that enough, or is that small enough bubble to get popped?
This is probably as big as you'd want to see, and that's probably just the transition from the new material. You can see like this bubble, that's fine.
Okay.
So plug it into here. And now we will go, now that everything's set up, we're going to go back to the computer and we're going to export that sliced file that we created, right? Or if someone has a sliced file that they created that they want to try to print, we can try to print it. Does anybody have one that they want to print right now?
I do, but I can't stay, so that's.
Okay.
I mean, until.
Yep, I gotcha. So yeah, we'll just go print my example just so you can see what's going on.
You want the camera off?
Yeah, it's spun.
Is that a thumb drive you're going to have to put in?
Yeah, so there are two thumb drives. The one labeled 1 is for the Moore 1, and the one labeled 2 is for the Moore 2.
So when we have files ready, grab that.
Yep.
and drop it on there. Okay.
So I am back in my slicer. Let's see what we have. So we'll print this with, 10% infill. That might be enough. I don't know that we'll run through this whole print. But here's our print, estimated 33 minutes. Notice when I have a flash drive in here, there's this extra icon that shows up by export G-code that looks like a flash drive. If you click that, it'll just automatically open up the flash drive to let you save it. And all of these files end in .g-code. That's the format that the machines use. There's likely going to be a bunch of other files from other people on these drives, so make sure you name it something that makes sense. So I'll just name this Clay Work Studio example week 2. Save. And now you can see down here, exporting finished, and then it even gives me an eject button. So the process is pretty seamless. So I've ejected it, I can take this out, and now we can walk over to the machine and actually start a print. So the flash drive locations are a little bit different on these machines. For the Moore 1, it's on the left side by the screen over here. For the Moore 2, it's on the right side over here, but it's still a USB drive. And here is the number 2 flash drive. I'm going to leave it in the machine so it doesn't get misplaced. So we have our paper down. We've got everything leveled. We are kind of primed, but not all the way primed yet. So at this point, I'm going to go into manual, raise it up a little bit so that I have room to catch anything that's coming out of here. Because we cleared the tube, but there's still unknown whatever in this part, right? So now we'll go back to materials. It's on both extruders now. So now we're going to have it prime both. And you'll notice it'll take a couple seconds for this to start building up pressure. I'm watching this bubble right now just to see the progress of it. Here, we'll put this underneath. And it will be very noticeable when we go to, from whatever was sitting in here to fresh clay. Because it's going to kind of splurt out of here, and then eventually it'll come out as a nice steady stream. Yeah. So I'm happy with how that looks. It's not, it's coming out at the same rate. There's not any bubbles in it. So that looks pretty good. So we'll stop it. And again, now the timer's kind of running. I have maybe 20 or 30 seconds for this to stay primed. So I'll go back, go into the print menu. This is the file that I created. Select that and hit the play button. It'll go and re-home. One file at a time. And so this is that outline perimeter that's on by default, just to make sure that it's primed, right? If you see this coming out inconsistently, you might want to stop the print and prime it some more. So that where I had it just running into my hand, just to make sure all of the air bubbles and stuff were out.
So I noticed that exterior perimeter there, but I never knew what it was. That is the what was blue, and it's what printed first. What is that? That's part of your model?
It's just there to make sure that your priming worked. And it's a setting in there called the skirt and brim. Some things to note is that if you are watching this and you are finding that it is not extruding enough material, or it is extruding too much material, not enough to ruin the print, but enough that you're unhappy with it, there is a kind of quick change settings in here. While it's printing, there's a pause, there's a stop, and then there's also this kind of edit button. If you go into the edit, it's going to give you options for extrusion, speed, the pressure on this, which we won't need to change, the speed, which you shouldn't change off of 100, but this last one is the extrusion percentage. So this, you can feel comfortable changing up to 10% in either direction. So if you're watching this and you're like, these lines aren't squishing together enough, go into here and put it up to 105%. Or if you're like, this is getting way too blobby, go into here and turn it down to 90%.
You can see a little bit of kind of stuff coming out around that.
This is extrusion percentage. So this is inside the machine, right? Because that slicer wrote that file that said, when you're at this point in the print, squeeze this much clay out. This is a quick setting in the machine that says, take whatever the slicer told me and multiply by this percent. So if it's over extruding, then you can say, well, multiply by 90% so it extrudes slightly less, or multiply by 105% so it extrudes slightly more. If you find yourself that you're turning this to 150 or 50%, you've probably done something incorrect in the slicer. Either you have the wrong nozzle on and you don't have the settings corrected for that, or you had the Moore 2 selected when you were printing on the Moore 1, or vice versa. That's a good indication. Like, this can only do so much internally with what it's being given from the slicer. This is a pretty dumb machine. It's just following what the slicer gives it. So if you're adjusting it by that much, you shouldn't expect good results. But yeah, 10%, it might just be that you mixed this clay a little stiffer or a little less stiff. So you might need to adjust it by that 5 or 10%. But this is looking okay to me. It's coming out pretty good. So I don't.
The difference between these two machines.
So we are at 5. I don't want to keep you longer than you need to. I am happy to clean this machine up so you guys don't have to. I'm also.
Watch you.
Yeah, so I'm going to stop it and I can show you. But it takes some time to do this. Oh, okay. This is another good thing to see though. So now that I have this, right, I can unclip, assuming this is a full print. I have the plate, right? So I have the plate, and now I can go to my shelf or wherever I'm working on the bench and just slide that off. And now I can give it the hour or two it would take for it to be leather hard, and then I can peel it off of the paper. So that is.
And it doesn't take as much as other.
No, it dries pretty fast. One, because it's on the paper, which is going to suck a lot of water out of it anyway. And two, I think just because it's drying as it's printing, it has that advantage. One of the things that I've had to do for some of these prints, especially like this big vase, and you might find this, if it gets tall, it might start to slump. Put fans around it. Go steal some fans from the wheels and put fans around it so that the bottom layers are drying faster, so that it has something hardier to.
But didn't you have a problem with fan not like needing to move the fan around?
I had 2 fans at one point, yeah. So in terms of cleanup, here are the things that I like to do. So again, we'll go back into the tool menu and we'll move this up on Z just so there's room to get the little water container under it. I'm going to unattach the tube. And while I'm doing other things, I'm going to go into that materials menu, type back in 20, start this pushing out clay. It's going to make a mess, it's fine. Again, you can just unscrew it and then dig this out, but it's annoying. It will take just as much time to do this than it would be to just. So that's one of the steps. These metal rods are here because they are the length of these tubes. So this gets the clay out of the tubes.
And so, why aren't you just presenting into one of these guys?
Because that's full.
No, I just an empty one.
No reason. You can do that if you want to.
Hopefully we'll have a lot less than that.
Yeah, I mean, even that little example, that might take a quarter or a half of a tube. You don't have to make a whole kilogram either. If you want to make half a tube because you only have half a print, just know that if you're going to do that, move the extruder plunger out. Otherwise, it's going to take you 20 minutes as it tries to compress a bunch of air before it compresses the clay. Yeah, that's probably about half a tube, especially because it doesn't have a bottom. Printing the bottoms takes up a surprising amount of clay. If you want to print on a slab, I think I said this, but I'll say it again just in case. Just make sure you go into the level and re-level to the slab. If you're printing onto a slab, it is fine if it digs into the slab a little bit. In fact, you kind of want that. So unlike the paper, where if you're leveling it and it's starting to drag on the paper, that's too low. If it takes that first pass into the clay slab, it's fine. It's doing a good job.
Thickness of the slab and how much larger than the bottom should it be?
It's up to you how thick you want to make it. There's only so much room to level this, so you can't have like a half-inch slab.
Like 1/8 inch?
I usually roll it to 1/8 of an inch.
And then does the overhang, probably it's just easier to have a bit of overhang.
Yeah, and then you can trim it off. So again, like I said, it takes 4 or 5 minutes. Usually I'll be cleaning up other stuff, you know, like I'll have something at my workbench while this is doing its thing. So again, I don't want to keep you guys too long, but yeah, this is the process. So again, I will send out the video. I will send out that operator manual probably sometime this week. And then yeah, keep playing around with Fusion. Let me know if you have any questions. We're gonna do Blender next week. So no problem.
Anything we should do ahead of time?
Again, as long as you have it downloaded, I think you're okay. I think the biggest thing with Blender is if you open it, don't be intimidated. Blender does like 20 things, of which we're going to use 2 of the functions. If you want to export an STL from Fusion and import it into Blender, you can try that. But we'll walk through that next week too. So I would say keep working on Fusion, make some more interesting shapes. Now that you know what the restrictions are in terms of what to look for in the slicer, like now you have a better idea of what you might want to make and like what the limitations of this are.